Hello and welcome to another KeySmash Studios video. Today we're going to be going over some more of the basics of coding in Unity, mostly focusing on game objects and what we can do with them. Now there are a ton of different things that you can do with game objects. I'm just going to show you some of the more common ones, and we're going to continue building onto this as we go in and create a game. I want to show what you can do with a game object first. So this is the same scene we had last time, where we explored the order of operations in Unity code and sort of how that worked. This is the same scene. I've just dyed the cube green so we can look at it and do some things to it. I've created a script and attached it to our main camera. That script's name is Learning Game Objects. It should be pretty self-explanatory. We're going to go through some of these game objects and what we can do with them. So up top here, we can ignore the new color thing for a second. But I've just created a reference to that game object. If you remember last time in our code intro, one of the variables that you can create is a game object, and we referenced one called the cube1. In a different script, we're going to do something very similar. We reference the game object cube, and it's public, so in our Unity folder, all we have to do is just click and drag this cube right here into the cube slot. If you don't do this, you'll get a missing reference error or something like that. So if you get a missing reference error, just go ahead and make sure that you have stuff dragged to your scripts. So we've created a reference to this cube, and we're going to do things to it. Last time we learned a little bit about if statements. We're going to do that just with a slightly different thing this time. It's still an if statement. We're going to our update function. If you remember from last time, update is where we put a large part of our code. It's called once per frame, and every time the screen refreshes, it calls itself again. It's called separately from a lot of the physics, but all of the code that we're going to be doing today can be put into update. So in our update function, we have a series of code that I've already set up, and we're going to go through it. So we learned about if statements last time. If something happens, then do this. Otherwise, don't do it. So there is a function in C# called GetKeyDown, and this happens when you press a key down, and you have to give it something. So when I press the E key down, so if I give it the input where I press just the E button down, and when it hits the bottom of the keyboard, so like when I make the audible click here and an L pops up, it only triggers once. Only at the exact moment that the L hits down on the keyboard and triggers the sensor does this code execute a single time. There's another version of this, so if I do a quick comment here, if I do an input and I do a get key, it will go every time the screen refreshes while that key is held down. So there's a slight difference there. You can do get key or get key up. That happens when it's released. The moment that it's released, so for example, if you're doing like a jump thing and you want it to be jump as soon as I release this button or something like that, you could use get key up. It's just three similar ways to do something, which each one having just a little slight change in how it would affect the code. For the most part, though, you're going to use GetKeyDown. It's the most common way to do something, and as this is an intro video, we're going to try to go through all the most common ways to do something. So we have an input.getKeyDown with a key code E. What that's saying is if I press the key E, then I want to do something. Well, we set up this game object called cube, and we dragged our cube to it. And one of the most common things you can do with a game object is to turn it on and turn it off. So in Unity, one of the things you can do is come up here to the inspector and check and uncheck this checkbox and set it active and set it as inactive. And all that does is it just hides it in the scene. When it's unchecked, the engine doesn't render it, it doesn't calculate it, it remembers where it is, but only if it's checked does it bring it back into the scene and start calculating where this game object is again. So one of the most common things we can do is set a game object to active, or conversely set it as inactive. So when I press the code E, I go find the game object cube and I set it active, and then it gives it a Boolean. So is it true or false? False, it turns it off. And then if I press the code R, it sets it active to true. So let's go ahead and test this in the game, and I'm just going to comment one thing out right here so it doesn't do something crazy, but we'll get back to that in a second. So we have our cube just sort of floating here in the screen. If I hit E, that cube disappears. If I hit R, that cube appears. Great. That's one of the most common things you can do in code with a game object, is to turn it on and off. And we'll use that extensively when we start making a game. So now I'm going to undo my comment that I did here. And we're going to go down to the next thing. Another thing you can do with a game object is to move it. Now there's a few ways to move things in Unity. This is just one of them. Each game object has a transform. And a transform is sort of like the position of an object. So if you look at our cube in the Unity engine up here, you can see that we have this section here called transform, and the position, rotation, and scale, how big it is, where it is, which way it's facing, all that stuff is stored in this transform. Even when it's disabled, it still stores where it is. So we can do whatever we want to that transform. So for example, if we would like to, we can rotate it. So I'm going to rotate it 15 degrees per tick around the y-axis. So this is X, Y, Z. And if we come into Unity, we can see that up here in the top right, Z goes this way, X goes this way, and Y goes up and down. So we're going to be sort of spinning like a top when I hit play. So now we see the game object spinning. And it's going to spin because I didn't put a way to stop that. It just spins. And if we look at the if statement, we'll see why. This one, unlike the other ones, where it's not a key code, it's just, is this cube active in the hierarchy? And what that means is, in Unity, it comes to this window right here, the hierarchy, and says, is this cube that's in our script active in this hierarchy? If it is, then yes, execute this code. If it's not, then don't. So right now, it's active in the hierarchy, and it's spinning. And we are selected on the cube, so as soon as I hit stop, I hide the object. We can look over here to the transform and notice that the rotation is not changing. As soon as it's active again, then the rotation around the y-axis changes constantly. All right, so the next two that we're going to handle is another way to mess with that transform. So this is one way to move in Unity. It's not the most common way to move a character, but it is a pretty common way to move an object. So sort of like if you have a mechanic, a rule that you're trying to do in a game, and you want to move, like a ball or something else. If you want to move an object that's not the main character, one of the more common ways to do it is to translate its transform. So just like before, we have an input.getKeyDown. And when we hit the W key, we want it to go up. And when we hit the S key, we want it to go down. So just like with our rotate here, we have an X, Y, and Z system here on the translate. So I'm going to say cube.transform, give it a translate, so .translate, and then when I put in this translate, here we can delete this and then take a look at it. When I put in this translate, you can put a number of different things in here. If you are in Visual Studios, it'll tell you, if you use your up and down arrows, what you can put in here. But one of the more common things is just to use the flat XYZ values. So these are all floats, so I can label it as 0F, 1F, 0F, or I can just do 0, 1, 0, like below. C#'s pretty nice to us and lets us be a little more flexible. So whichever way you're more comfortable. So all this will do is it will go up 1 unit when I press the key code W down. So let's try this in our game. We have our cube, it's spinning. We can turn it on and off. If I hit the key code W, it goes up. And if I hit the key code S, it goes down. Now it's worth noting, if you're rotating While you're changing position, this can get really out of whack. So if I was rotating around the x-axis, my W position and rotation would affect how I translate. And that's because the translation happens relative to the cube as opposed to the scene as a whole. So if I'm looking at it through the camera, yes, it's going up and down relative to the camera, but as soon as it's not relative to the camera, it's still going up and down relative to itself, just not to the camera and how we see the scene as a whole. So it's just worth noting and keeping that in mind. The very last thing that we're going to do is show an example of a Get component. So when I hit the key code C, when I press C down, I want to create a new color. So you remember up here I said, don't worry about this new color stuff. So you can create colors in code. One of the ways we can create a color is with an RGB value. So I created a new color up here. It's just a private variable called of a type color. That's part of Unity Engine. So in our new color, when you create a new color, you can create it with RGB values. So float R, float G, float B. It has to be between 0 and 1. If I were to do like 1, 0, 0, it would just be pure red. 0, 1, 0 would be pure green, and 0, 0, 1 would be pure blue. Anything else is just a ratio between 0 and 1. So 256-bit color, I'm taking something that's mostly red, 213 of 256, a little bit green, and a little bit blue. So we're still going to get a vaguely red color. It just might be a little bit darker of a red as opposed to pure red. But we just created this color and named it new color. In our game object, we have this cube game object. One of the things you can do is get a component of the cube object. And what that does is it comes down here into this inspector and it finds a component called renderer. So on our renderer, it gives us our shader, and you can see our shader up here. And one of the things you can do with that renderer is select the material, just like you can here, material green. And then this is our material down here. So in code, we can do something similar. I want to change the color of that material, and in start, at the very start of the scene, I made a color. It's this off red color. And all I have to do is grab the component renderer. I want to grab the material attached to that component, and I want to change that color to the color I made at the start of the scene, which is like this off red. So when I hit C, I want to change color. So hopefully, if we've done this right, when we hit C in our scene, our cube will turn from a spinning green box into a spinning red box. And as soon as I hit play, since the change happened while we were in play, it swaps back to green. We don't have to worry about that changing stuff permanently or anything like that. So these are just some of the ways that you can use game objects. There's some of the more common ways. We can move them, we can translate them, we can rotate them, we can set them on, set them off, we can change something about them that we can find in the editor. This is one of the most common things that you'll do in Unity code. You'll get a component of a game object and do something to it. Particularly when we start doing player controller, what makes our player move when we start moving around, something like that. When we start doing that, we're going to be doing lots of these .get components. All it's going to let us do is change something that's in this inspector here. It's one of the most common things you can do with a game object, and it's a really neat functionality that's going to allow us to code a lot of different and intricate things in our games. As always, if you have any questions, please let me know in the comments down below. Feel free to join our Discord. We have a questions and support thing there. There's lots of people that know how to code in our Discord. Lots of really great people. You should jump in, join the community. It's a great place. You can check out our streams on Twitch. We stream a couple times a week. As always, if you found this to be helpful, please consider liking, commenting, subscribing, all that jazz. It really does help us out. And hopefully we'll see you next week.